Bioeffects. Always when anyone make a medical test, you have the part of the benefits and the risk. How good, how necessary is the examination, and how many risks the patient must take in this test. This class is to discuss the risk that take the people with ultrasound. Dosimetry is the science that measures the characteristics of ultrasound producing biological effects. There are dosimetry also to X-rays, but in this case we are going to discuss the dosimetry in the field of ultrasound. We know that a very high intensity and with scanning a lot of time, ultrasound can produce damage. The example here is the lung of a rabbit. The red area, the red spot, show that it's possible to produce harm in a rabbit with ultrasound. But in this moment there are no case of biological effects and tissue injury in diagnostic ultrasound with the standard intensities that we work. No case. But for study this phenomenon we have two different approaches. The first one is the mechanistic approach. The mechanistic approach must propose a physical mechanism that produces this bioeffect. After this, must perform a theoretical analysis to estimate how bioeffects can be produced at different exposure level, more energy or more time, and at the final identify the cause-effect relationship. That means how many energy you must put with ultrasound to produce tissue harm. The empirical approach is different. The empirical approach is about information in medical charts about how much persons are suffering for bioeffect produced by ultrasound, and in this form identify one exposure-response relationship. Empirical is based on experience data, not on theory. To have a firm conclusion about bioeffect and the danger of ultrasound, you need to have conclusion in the theory approach plus observation. Mechanism of the bioeffect. There are three mechanisms that ultrasound can produce harm. The first one is the thermal, that means heat. The second one is called cavitation. It is the produce of bubbles inside the body. And the third mechanism is the mechanical interaction, that is all the bioeffects that are not thermal or not cavitational. Thermal mechanism propose that ultrasound may induce bioeffect by heat, by elevating tissue temperature. But everybody knows that you can touch the transducer and you never find the transducer is heat. But it's also to remember that attenuation, that is the change of ultrasound in heat, is a normal ultrasound phenomenon. When ultrasound goes through the body, energy of ultrasound is changing in heat. This is called absorption. In other words, in theory, it's possible that ultrasound can produce harm in patients through the production of heat. Normal body temperatures are 37 centigrade degrees. Life processes do not function normally at other temperatures. But it's quite common one person have fever, or you go to the beach, or you take a lot of heat in the kitchen and nothing happens. The body can deal with minimal change in temperature and continue working normally. Is this for that must be a combination of temperature and a long time to produce these bioeffects. How much time? How much time we scan a person? How much time the machine is producing ultrasound? How much time the machine is not producing ultrasound because it's waiting for the echoes. This is transmission and reception, and remember that the pulse is very short. More temperature, you need less time to produce harmful effects. But there are no confirmed bioeffects by elevation of 2 centigrade degrees above the normal in exposure of less than 50 hours. Of course, we know perfectly that you don't need 50 hours to scan a patient. This is a big number of hours, and this is all the scope of ultrasound. Maximal heat is related to SPTI, spatial peak time average, the place where there are more energy and all the time you are scanning the person. This is that we use in ultrasound, SPTA. It's logical that the fetus and more the embryos are less tolerant to temperature elevation, and this is for that it's logical to be more careful when we make ultrasound in pregnancy less than 3 months. And of course it's logical to suppose what a structure that absorb heat, like the bone of the cranium, are more prone to produce elevated temperatures. There are developed something that is called thermal index.